Now, coming to the basic elements, we have resistance, inductance, capacitance. Resistance, inductance, capacitance. If you take the resistor here, if you take the inductor here, if you take the capacitor is here. Inductor, capacitor is here. What is meant by resistance? What is meant by resistance? It is a virtue of property which opposes the flow of current or flow of electrons. Resistance is a property which opposes the flow of current or flow of electrons. That is nothing but a resistance. You know what is the units for resistance is ohms. Ohms. What is the basic formula for resistance? R is equal to? What is the basic formula for resistance? R is equal to? The resistance basic formula R is equal to rho L by A. R is equal to V by A is not a basic formula. That is the formula generated from the Ohm's law. But for example, if you take this marker, you want to tell what is the resistance means. Sir, you bring voltmeter, bring ammeter. I will keep voltmeter here, ammeter here. I am going to tell the reading of the resistance. Not like that. The resistance we are going to tell what is the length of this material, what is the area of cross section, and what is the nature of the material it is made. Based on that, we can able to determine the resistance value. Like that, the resistance is equal to R is equal to rho L by A. This is in ohms. Sir, what is the resistivity? What is meant by resistivity? Resistivity or specific resistance. Specific resistance. Specific resistance. Where R is called what? Resistance. L is called length. A is the area of cross section. And rho is the specific resistance or resistivity. Now, I have a small question for you. Suppose you take one material, a stretched material. You bring the length double. Stretched material I am talking. If the length is doubled, volume remains constant. What happened to the resistance? Suppose we have a material of length L. We have material of length L. For same volume, we are making this length is double. Length is double. What happened to the new value of resistance? Tell me, what happened to the new value of resistance R2 as compared to the R1? Is it increases or decreases? If increases or decreases, how many times? Yeah, I will give the answer. The resistance will become 4 times. The resistance will become 4 times. Are you got it? Sorry, you said only length is doubled. How this becomes 4 times, huh? One condition I told you. What is the condition I told you? Volume remains same. Volume remains same. Volume remains same means material you are not changing. Same material you are using. So that what happened is, if you are making the length is double like this, length is doubled. Now this is the new value of the material becomes like a 2L. This is 2L, and this is the area of cross section became as A by 2. Earlier it is A, now it is became as A by 2. Now substitute this formula here in these conditions. What is it? Rho does not change. Length will becomes double, 2L. Area becomes half. This is 4 rho L by A. It became as 4 times. It becomes as 4 times. It is not 2 times. When it is 2 times, sir, when it is 2 times, for example, this is the material. This is the material. If I can add one more material like this in series with the same length, it has a resistance of R. It is also having a resistance of R. This is R, this is R. What it becomes like? 2R. This is R, this is R. It becomes like a 2R. They are in series. Are you got it or not? But what happened in this case? What is the observation? Here volume has changed. Suppose this is one resistance here, this is another resistance. You are connected like this, coupled like this. Then it is R, this is R. It became as 2R. But what is our question? This is the material we are bringing like this. That is the difference. Are you clear? Because of that, our resistance will becomes like a 4 times. Our resistance will becomes like a 4 times. Now, another question I am asking here, in the same format I am asking one more question. If the length is increased by n times, 4 times, if the length is increased by 4 times, for a constant volume only I am speaking, nobody will not ask without constant volume. If the length is increased by 4 times, what happened to the resistance? New value of resistance. How much times it is increasing? For a constant volume, the resistance is directly proportional to L square. Resistance is directly proportional to L square. What is L? Length. If L is increased by n times, our resistance is increased by n square times. N square times. If the length is increased by 3 times, our resistance value increased by 16 times. 9 times. Like that we have to answer. Okay, most of the students are given right answer, 16. Because of that, I can understand whether you are able to follow me or not. Initially you told 2 times, but finally after the explanation you are given 16 times. That is a good symptom. You understand this topic. You got an idea about this topic. Now one by one we will talk inductance and capacitance. First we are talking the resistance itself. Anyhow, the rho is equal to RA by L. Rho is equal to RA by L. What are the units for resistance? Ohms. What are the units for area? Meter square. What are the units for length? Meters. This square and this meters gets cancelled. Units for resistivity is ohm meters. Units for resistivity is meters. Ohm meters. Hello. Now we have one question. Sir, what is that question, sir? Suppose for a constant volume, if the length is increased by 2 times, what happened to the new value of resistivity? Initially, we have resistivity of rho 1. After increasing of length by 2 times, what happened to the resistivity rho 2? Is it increases or decreases? What happened? You see, it is a resistivity. Resistivity is nothing but specific resistance. It is not depending upon the length, it is not depending upon the area, it is not depending upon any other factors. It depends upon the nature of the material. Otherwise, temperature. It may depend upon the nature of the material or type of material. You see, you take this wood here, you take this, it has some resistivity. If you take this water bottle, it is made with some other material, it has some resistivity. If you take this marker, it has some resistivity. Like that, copper will have some resistivity, aluminum will have some resistivity, gold will have some resistivity. That will not depend upon the length and area. Why? Because, what is the reason for that? Why, sir, it is not changing? First of all, you need to understand what is the definition for a resistivity. You need to understand what is the definition for a resistivity. Resistivity is defined as it is the resistance offered between two opposite phases of a unit cube of material. Once again I am repeating. It is the resistance offered between two opposite phases of a unit cube of material. See here. This is the 1 unit cube. All sides it is same. It is a unit cube. So this one, everything. It's a cube. For this unit cube, what is the resistance offered in this phase and back phase? Two opposite phases, or otherwise from here to here, two opposite phases. It is fixed here. It is fixed. Even though if you increase the length, but resistivity definition will not change. It is fixed for a unit cube. That is the reason it remains same. It remains the same. Because it is a same material. So resistivity is depends upon the nature of the material. Sometimes resistivity is depends upon the temperature. Effect of temperature is very small. Effect of temperature is very small. So now, I have one small question for you. Sir, what is the units for conductivity? Tell me. My dear students, you need to understand. Conductance is different, conductivity is different. Resistance is different, resistivity is different. Resistance units are ohms. Resistivity units are ohm meters. Conductance units are mho or Siemens. Conductivity units are mho per meter. 1 by ohm meter. 1 upon ohm meter. If you take the conductance, G is equal to 1 by rho A by L. You make inverse for this. A by L. Z is equal to 1 by rho, we can denote as sigma. Sigma notation is used for conductivity. A by L. So, what is the units for conductance? Conductance has units of mho or Siemens. And the conductivity sigma is equal to G into L by A. G is nothing but mho meters by meter square. This square gets cancelled, which is equal to mho per meter or 1 by ohm meter we can write. This type of silly mistake sometimes we are going to commit in exam. We are remembering the conductance, we are not remember the conductivity. Difference you are not finding by sharpness. So, the question conductance is different, conductivity is different. Is it clear? How they connected in series, parallel, series and parallel combination. All these things in further classes we will get it. All these things we can get in further classes. So resistance I told you briefly. And you know what is the resistance formula? R is equal to rho L by A. R is equal to V by I. V is equal to I into R. Power in a pure resistor P is equal to VI R I square R or V square by R. Power dissipated. Power dissipated. These formulas you know very well. Simple formulas. These formulas are very simple. Now, coming to the inductance. Coming to the inductance. Sir, now what is the definition of an inductance? What is the basic formula for inductance? What is the basic formula for inductance? L is equal to. Basic formula for inductance is mu naught mu r n square A by L. A upon L. This is the basic formula for inductance. How like Ohm's law is written R is equal to V by I, we can write here inductance L is equal to flux by current. Because this scenario is different from this scenario. Here flux is coming to the picture. There is no flux here. Only current and voltage are the parameters. Here voltage will be there. Flux will also be the involved, additional factor involved. L is equal to N pi by I. If you want to write more clearly, you can write as N pi by I. N is number of turns. Pi is the flux. I is the current. This is the basic formula. This is the basic formula. Sir, why I written this formula, sir? As usual, the inductance is also depends upon the nature of the material. That is mu r. It depends upon the area of cross section. It depends upon the length. As like resistance, length, cross sectional resistivity, nature of the material, area, nature of the material, and length. Sir, what is the one important property of an inductance? You should know some important property will be there for inductance. What is that important property? Can you tell what is the important property for inductance? Current through the inductor cannot change suddenly or abruptly. Current through the inductor cannot change suddenly or abruptly. That is one of the important property. You see here, for example, it is a resistor. It is a resistor. In this resistor, one switch is placed here and voltage V is applied here. Suddenly, at the instant of t0, I close this switch. At the time of closing the switch, what is the current in the circuit? I is equal to V by R. But this is not the case in the case of inductor. If the same situation will rise just like this, when you have a switch here and the power supply V is here, suddenly when switch is closed, current to the inductor does not changes. It will not allow the sudden change in current. Because inductor, capacitor are the memory storing elements, energy storing elements. The property of element is like that. It will not allow sudden changes. But it will not allow sudden changes in the currents. You see, what is the voltage across the inductor? V is equal to L into di by dt. V is equal to L into di by dt. Now you see, my dear students, suddenly when I switch the close at the instant of t0, for example, I am making t0, what is going to happen? What is going to happen entire this equation? If the denominator has 0, what happened to your voltage? Your voltage will become like infinity. Voltage infinity means what is the current flowing in the circuit? Voltage infinity is nothing but when the voltage becomes infinite, it becomes infinity when it is a open circuit. It becomes infinity when it is a open circuit. When it is a open circuit, then what happened to the current in the circuit? Is 0. So that is the reason. Mathematically, we can identify why current is not suddenly changes. Theoretically, it is an energy storing element. That's why even our mind, you see, our mind is also an energy storing element. It cannot allow the sudden changes. Suppose you are staying in one home. Immediately, if you want to go for another home, you want to stay. Our mind will relent. Why should I go? I will stay here. such a element. Inductor and capacitor are such elements. Now this is what. Sir, I have a small question for you. Suppose I need to change the sudden change in the current in the inductor. When it is possible? Is it possible or not? If possible, in what condition it is possible? So, as we know, that point you write down your notes. Don't forget the point. Current through the inductor cannot change suddenly. That point is written. Next again, what is my question is, why the current is not sudden changes in the inductor? Suppose I want to see the sudden change in the inductor current. What should I do? What should we do? If you want to see the sudden change in the, if you want to see the sudden change in the inductor, we must apply a voltage of impulse function. We have to apply the impulse function. At t is equal to 0, you must have a signal like this. T is equal to 0, you must have a signal. It is an impulse function. At t itself, we have to provide infinite voltage. Practically not possible, but theoretically speaking, current through the inductor is possible only when if you apply a, what is that? Impulse function. Sir, again this topic I will tell you, I will discuss while we are discussing about the transient analysis. There this property is very, very important. There this property is very, very important. Now, how to find the current? Voltage across the inductor is given like this. How to find the current? How to find the current here? V is equal to L into di by dt. Suppose if I want to find the current, how can I find the current? So V by L into dt is equal to di. If I can integrate this one from 0 to t, what this becomes like? I is equal to 1 by L integral V dt. Both sides we can make integration. This is the current equation in a pure inductor. What is that one? I of t. This is limits are from 0 to t. Limits are from 0 to t. If you substitute these limits, what we are going to get? I is equal to 1 by L integral V dt plus I naught we can get. Sir, what is that I naught, sir? Can you tell what is that I naught? Can you tell what is that I naught? It's a constant now. When you integrate it, you will get the constant. What is this I naught? Suppose if inductor is having initial charge, if already inductor is having initial charge, that inductor acts like a current source. It acts like a current source. If does not contains any energy storing before the operation, we are going to get this is only the equation. If already inductor is stored, we have to take I naught. Sometimes our inductor is also considered as a current source. When that considered as a current source means, if inductor is already storing the energy, suddenly when the switch is operated, it acts like a current source. It acts like a current source. Sir, then how can you calculate the power, sir? How can you calculate the power? How can you calculate the power? Power P is equal to V into I. Power P is equal to V into I. So what is your V? L into di by dt. L into di by dt into I. How can you get the energy? How can you get the energy? L into I into di by dt. Energy formula is what? Power into time. Energy formula is power into time. Then entire equation if you integrate here and make dt is here, dt gets cancelled. What is this? L into I di. If you integrate I, what you are going to get? I square by 2. What this becomes like? L into I square by 2. that is half Li square. This is the energy stored in a inductor. Power in inductor is this formula. Energy stored in inductor is this formula. Current in inductor is this formula. Voltage across the inductor is this formula. These are all the important formulas. Not only here, again, this is required for many times in our subject.